Okay, good morning to all. Today we are going to start the next part of this unit. We have to talk about the one question that is a very much popular one. What is ionic strength? Discuss Debye-Hückel limiting law. As already we have seen the definition of this particular ionic strength. Ionic strength is nothing but the half the sum of the product of the molality and square of the valence of each ion in the solution. And it is in the formula form. It is written as mu is equal to half summation mi zi square. As you already know that mi is nothing but the molality of the ions, and zi is nothing but the charge or say valency carried by the ions. Okay, this is about the ionic strength. And then what is the Debye-Hückel limiting law? This Debye-Hückel, these both are the scientists put their work collectively to show the relationship between the ionic strength and the mean ionic activity coefficient. Especially this both the scientists Debye and Hückel collectively put efforts to show the relation between the mean ionic activity coefficient and the ionic strength by the relation log gamma plus or minus. Log gamma plus or minus is equal to minus a z plus z minus under root mu, where A is nothing but a constant, depends on the nature of the solvent and the absolute temperature. This equation, whatever the equation that we have seen, log gamma plus or minus is equal to minus A, Z plus Z minus under root mu is also known as the Debye-Hückel limiting law. When we talk about the aqueous solution and at the 298 Kelvin means the 25 degree centigrade temperature, and when we talk about the aqueous solution, generally we are using the water as aqueous medium. For that, A is having the value 0.509, and therefore this Debye-Hückel limiting equation will become log gamma plus or minus is equal to minus 0.509 z plus z minus under root mu. Instead of A, we are going to put the value 0.509. Okay. According to this law, Debye-Hückel limiting law equation, the plot of log gamma plus or minus against the ionic strength should be the straight line with the slope minus a z plus into z minus. This is the plot you get after the plotting log gamma plus or minus versus the under root mu, or say you can say the ionic strength. You will get that particular straight line graph, okay, with the negative slope is equal to minus a z plus into z minus. Then for particular univalent type of the electrolyte, that slope will be the simply the A, and for unibivalent electrolyte the slope is having the value minus 2A. Okay, you can take the example and you can try for this particular thing. We can perform that experiment in the laboratory using the that potentiometer. Log gamma plus minus we can calculate easily, and afterwards you can calculate the ionic strength also. This is whole about the ionic strength and the Debye-Hückel limiting law. Sometimes the 5 marks question comes in the exam based on this part. Will define the ionic strength and discuss the Debye-Hückel limiting law for this particular part. Then we will see the video.
Okay, let us now continue with the Debye-Hückel limiting law. What is Debye-Hückel limiting law? It gives the relation between the mean activity coefficient. This is mean activity coefficient gamma plus or log gamma plus or minus equal to minus a. A is a constant modulus of z plus z minus modulus I to the power 1 by 2. Okay, now this gives the relation between the log of mean activity coefficient and the ionic strength. Ionic strength we have seen in the last video. Ionic strength is can be calculated for a given electrolytic solution. So if we know the ionic strength, we can calculate the ionic strength. We know the formula, and